So, as I said earlier on, sometimes integration by parts will result in an integral of the form integral of v du. That will be identical or the same as the original function as I was telling you up here, right? So for that matter, if we are alert and notice that this has happened, we can find a very simple solution to it by doing some simple algebra. So let's see how this can be done by using an example. So first of all, let's consider this example. Evaluate integral of x ln x. I believe that we have already looked into this example, but I know that this is one of the question or example that will result in a recurring integrals, and doing so we'll be able to get a clear understanding of whatever we are trying to mean over here. So when you are solving an integration by part question and then you see that whatever you are getting is being repeated or identical as whatever question was given to you, that's a good one, and it will help you to arrive at your answer as quick as possible. So using the results, or let's say evaluate this. I don't have to develop the saying using the result in the second attempt, but I know. So let's see something here. Because we have already evaluated something like this in my previous tutorial, we came to the fact that our u should be equal to ln x based on the assigned function that we gave it to it. Based on the assigned function that we gave it to it. And therefore, our dv was also assigned as dx, because when we take everything here for it as u, then the rest will be dx, or 1 dx. And in doing so, we were able to come out, if you have not watched the previous tutorial, please go and watch it. We were able to come out as du equal to 1 plus ln x dx by using the product rule to find du. And dx is here because dx is there because it's over dx, but I decided to multiply through by dx, right? Through by dx. Let me use dots so that you don't get confused. Dx, and this cancel out. So that's where we're able to get our du equal to 1 plus ln x dx. And then based on this dv, we are able to get our v to be equal to x. And substituting it into the formula, which is integral of u dv is equal to, or u dv dx, u dv equal to uv minus integral of v du. We have everything that we need to find, and therefore we substitute it into the question, and we are going to get the integral of x ln x dx, which is equal to x ln x. That is our u, and our v here, it was what? X multiplied by x minus the integral of x into brackets, let's say 1 plus ln x And then don't forget that we have our dx here, because that is our du. This is our du. This is what we have. And based on this, we need to evaluate the integral at the right hand side, and we can take it alone. So based on that, we can decide to expand whatever is here, because this x is multiplying everything inside the bracket. So we can see that we have our x ln x multiplied by x, right? Minus, when I multiply x times 1, it's x, which is integral. And then, because it's in brackets, plus x ln x dx. So this is what I have. X times x here is what? X squared. So x squared ln x, right? Minus, now I have my integral of x here dx, and here this minus affects everything in the bracket, so minus my integral of x ln x dx. And don't forget that here is integral of x ln x dx. So as you can see over here, this original function that we need to integrate is same or identical to the simplified function that we have gotten here. So what we can do is that since this original function has been duplicated in our result, we need to send this one to join to the original function, because they are the same. That is grouping like terms. So when we are doing that, this is minus here. When I send it here, it becomes positive. So I have integral of x ln x dx over here, plus integral of x ln x dx over here, which is equal to x squared ln x minus integral of what? X dx. Now integral of x dx becomes simple. We can do that, and adding this 2, we are going to get 2 times of integral of x ln x dx, which is equal to x squared ln of x minus integral of x dx. We are going to get 1 over 2 x squared. So in doing this, now the question which was given to us to solve, it's to evaluate x ln x dx, not 2x ln x. So what we need to do is divide both sides by 2 to get integral of x ln x dx, which is equal to 1 over 2 x squared ln x minus this one, 2 times 2 give us 1 over 4 x squared. And don't forget that this is an indefinite integral, so we need to add your plus c. So this is the result that we are going to get. So this is in the case whereby the resultant of whatever you are getting after applying the integration by parts kind of duplicate the original question which was given, and in that case you need to group like terms and then add them out. If there's any constant differentiating the original function and whatever addition that you did, you divide the constant out or multiply it out, whatever you will get with the original function, and then evaluate whatever is on the right hand side, and you will be good to go. So this is another case that you may encounter whenever you solve some of the integration by parts question. Thank you.